வணக்கம் மாணவர்களே. Today we are going to discuss about important aspects of electric field. So what are all the important aspects? If the charge Q is positive, then the electric field, the charge Q is positive, then the electric field at a point here is இடத்துல ஒரு பாயிண்ட் எடுத்துப்போம். இந்த பாயிண்ட்டை வந்து we can call it as P. அப்போ the distance between this point charge from charge Q to this particular place we can call it as R, so that the electric field, this is a positive charge of the electric field which will act away from the point charge, it is acting points away. Okay, suppose if you take the negative charge here, if you take the negative charge Q, you can consider the same point P. So what happens is this particular place here there is a negative charge, means the electric field will act inward direction. The electric field will act inward direction. This is what the electric field, and this is what the electric field. Okay, so the unit vector which is going to be acted, this is what the distance between this. So the unit vector which is acting here is, so the unit vector which is going to act here is what r cap, the same way r cap. So the conclusion is, we can write, if the charge Q is positive, if the charge Q is positive, then the electric field points away from the source charge. Points away from the source charge. If the charge Q is negative, if the charge Q is negative, then the electric field point towards the source charge, points towards the source charge. This is what the first aspect of the electric field. So here we have explained here, whenever there is a positive charge, there is an electric field which is acting away from the point charge. Whenever there is a negative charge, which will always act towards the point charge which we have taken. So we go for the second aspect. The second aspects of electric field is, we can take like this. Suppose we take the positive charge Q. If the charge Q is the positive, we can consider, we can take the same point P, which has the distance from the source charge to this particular place. There is a electric field is acting here, we known well. This is the, we can consider, this is the test charge Q naught. We consider test charge Q naught. There is a force, there is an electric field acting this particular point is, we know that there is an electric field which is acting away, E vector. So the force acting at this particular point P is, we can very much write, we know E is equal to F vector Q naught, so that we can write F vector is equal to Q naught E vector. F vector is equal to Q naught E vector, which is acting away in this direction. There is a unit vector which will act away from the positive charge. This is what r cap, this is what distance from the positive charge to the point P. So now if we take the negative charge here, if the Q is the negative charge, we can consider the same way the point P. This is what the distance from this R. There is a unit vector which is going to be again acting in this direction. Okay, there is an electric field at this particular point which will act inward, because this is a negative charge which will act inward direction. So here we are going to keep the unit positive charge q naught. The force acting here is the same way, F vector is equal to q naught E vector, but this force which is acting towards this charge, because there is attraction force here, because this is negative, this is positive. Here there is both are positive charge, so this the force is repulsive away. So this is what we should understand here. So here this is the positive charge, we should understand this is a positive charge. So that is what we are saying, that the force is acting inward this direction towards plus q. Here this is the this is a positive q naught, so that there is a repulsive force which will act away. This is a here also we are keeping the positive test charge, so that it will act towards a charge q, minus q. So this is what the second aspect of the electric field. Now we go for the third one. We know the equation E vector is equal to q by 4 pi epsilon naught r squared into r cap. This is what the formula for the electric field. Here electric field is the independent of the test charge q naught. So this particular place, the q naught, wherever we kept q naught, this is a test charge that is very small comparative with the this charges, source charge. So this source, the discharge should not affect the electric field of this source charge. This is only depends upon the source charge only. So we can write the electric field is independent of, here the electric field is independent of test charge. Electric field is independent of the test charge, independent of the test charge q naught, and it depends only the electric field. It depends only on source charge q, only on the source charge q. So we know that the electric field is only decided by source charge, not by the discharge. This we should understand here. So now we are going to see the fourth point. What is the fourth point here? So now I am going to take a positive q charge. I am going to take, this is what the positive charge. Okay, I am going to take a point. There is a point nearby the positive charge. This is a positive charge q nearby the positive charge. This is what the point P. I am going to little bit away from the positive charge, another one point. This is what q, and I am going to take another one point some distance from the, yes, actually this distance is little bit this distance is little bit away from the point P, but it is little bit lesser than that of the q. So like that you can consider. So you can you can call it as r. You can put it here. This is what r. This is PQR. I am going to choose the three points. Okay. So now this is the distance. This is very near to this. So that the electric field acting here is, this is what little bit higher distance. This distance is it is a greater than that of the B, but lesser than that of the Q. So that according to the distance, the electric field also change. Here this is very near to the positive charge, so that the electric field vector, which is length, little bit higher length, and R, this is the distance of the R is little bit higher than that of the B but lesser than that of the Q, so the electric field will have this much. The length is shows the magnitude of the electric field. Length is shows the magnitude of electric field, and I am going to take this is the point Q is away from the greater distance comparative with the point P and R, so that it has a very less electric field magnitude. So the same way, if you take the negative charge, this is very near, this is little bit away, this is still higher distance, so that you can consider this is the charge Q. So you can consider like this. The electric field acting here is this particular place, because this is very near, so that the electric field vector is higher. This particular place comparative with this little bit small, but comparative with this a little bit high, here little bit small. This is what the electric field vector. This is the EP, because this is the point P, this is the point Q, this is the point R, so that this is EP, this is the ER, this is the EQ, this is the ER, like that you can consider. Here also this is what the point P, so that EP vector, this is the EQ vector, this is the ER vector. So when the distance is higher, the electric field is reduced. When the distance is near, the electric field is higher in the magnitude. So that we can conclude here is, when the distance is more from the point charge, the electric field also lesser. When the distance is increases, electric field is decreases. And a different point, it has a different direction and a different magnitude. So conclusion from this particular point is, the electric field is a vector quantity. Here we can conclude the electric field is a vector quantity. Electric field is a vector quantity at every point in space. At every point in space, this field has unique direction and magnitude. Okay, you can see here, this is a different direction, this is different direction, this is different direction, here also this is different direction, this is different direction, this is different direction, but the magnitude also changes according to the distance which we have placed. So in space, this field has unique, the distance increases. Further infer that the distance increases, the electric field distance increases, the electric field decreases in magnitude. So this is what the fourth aspects of the electric field. The important aspects of electric field, point number 5. So we know that there is a source charge Q, whether it may be the positive or negative. We have a test charge, that test charge also positive. We know this is what Q naught or QO. The test charge is always we are taking very small. So why? Because whenever we are, this test charge should not affect this source charge. So when we bringing this test charge, which will not move this source charge. Okay, suppose you are bringing this Q naught from somewhere else. So by now this is a Q, it may be change the position of this particular charge, source charge. So it should not affect the source charge. So that is what we can conclude this. The test charge is the test charge made. The test charge made sufficiently test charge made sufficiently small such that the test charge made sufficiently small such that it will not modify the electric field of the source charge. The test charge made sufficiently small such that it will not modify the electric field of the source charge. That means if you are bringing this Q naught near to the Q, it will not alter the position of this source charge. Okay, we go for another point. We go for the next point. Point number 6. So we have we kept the point charges. If there are point charges are there, we know the equation. So the equation is E is equal to Q by 4 pi epsilon naught R squared R cap. This is what the formula for the electric field. This formula is only valid for point charges. This is only valid for point charges. That is discrete charges, point charges. Okay. So if you have for continuous and finite charge, suppose if we take continuous and finite size charge distributions, we should use the formula for this electric field. E vector is equal to integral of dq by 4 pi epsilon naught r squared, and r cap. So we should use the integration technique to find the electric field at a point due to the continuous and finite charge distribution. So we go for the 7th point. There are two kinds of electric field. Two kinds of electric field. So one is uniform electric field and another one is non-uniform electric field. One is uniform and another one is non-uniform electric field. Actually, uniform electric field is nothing but constant electric field. We can write constant electric field. Non-uniform electric field is not a constant electric field. Suppose you take the electric field is looking like this. So what happened is uniform electric field, electric field is the vector quantity, so that we can draw like this. So all the arrows are looking the same length, so which is acting in the same direction. So like this. So this is what called as a uniform electric field, because the direction and length of this arrow, actually this electric field size are so same. So in magnitude and direction are same. That is what called as a uniform electric field. This is a uniform electric field. Okay. So the non-uniform electric field. What are all the non-uniform electric field? So non-uniform electric field you can very much write. So the direction the magnitude, the direction is same, but the magnitude is keep on reducing. So the same way, so this is, you look at this, the electric field when it is going, the direction is same, but the magnitude is changing, so that this is a non-uniform electric field. The point charge, which will always provide a non-uniform electric field. You consider this is a point charge, this is a point charge. The electric field, the nearby, the magnitude is more, and when it is going distant, the electric field is getting reduces. The same way you can draw like this. So the same way you can draw here also. When the distance is increases, okay, here there is a more electric field, here there is a less electric field. When it is go further, the electric field size magnitude correct. So magnitude and direction both are changing here. Here magnitude alone changing, direction is same. Here magnitude and direction both are changing. And another one also is there. You can consider non-uniform electric field. So we can draw one more non-uniform electric field also. So this is what. Here also the direction and the magnitude both are changing. Direction and magnitude is both are changing. This is also non-uniform electric field like this. These are all the non-uniform electric fields. This all non-uniform electric field. Here magnitude different at different point, direction same. In the second figure, magnitude and direction both changes. Here direction and magnitude both changes. For the point charge, if it is a positive point charge, the electric field is changing radially outward. When the distance is increases, magnitude is changing, and each and every point the direction also it's going to be changed. It's going to be changed. This is what about the two kinds of electric field, that is for uniform electric field and non-uniform electric field. So this is what the important aspects of the electric field. So I hope so you will understand better this concept. So we will see the next class. Thank you very much. Bye.